Good morning and good afternoon, good evening. My name is Kausik and hopefully you are able to see my screen. So we will talk about a bit on various power saving features that were introduced in 3GPP, and from Qualcomm side, we are working closely with our customers in China and elsewhere to make the ecosystem work and be able to realize the benefits. At a very high level, the power saving features that were introduced in 3GPP release 15 and 16 are captured here, some of which are already implemented in your network and few of which are going to come up. And connected mode DRX, starting with the first one, you are pretty well aware, has been in existence since LT days. Bandwidth part is something that had been introduced in NR, did not exist in LT. And this is also commercial in China. Skip uplink, transmit dynamic. This is a new thing in NR, and we are expecting commercialization and rollout very soon, followed by UE assistance information, where UE is allowed to let the network know what it is preferring, and network accordingly could give the grant. And then switching gear to release 16 items, the new things that had been introduced are wake up signal, so that UE does not have to continuously monitor PDCCH even when it is on or reading PDCCH. There could be an indication to let the UE wake up and read when there is something in it for the UE. Configured grant is a modified version of uplink pre-scheduling that is already out there in your network. But benefit here is UE is aware, unlike uplink pre-scheduling, when the grant would come, so that in between the UE could sleep and accordingly save some power. Skip uplink transmit dynamic has a modified version of it in release 16 as well, and we expect to see commercialization of that. From subsequent slides, we will take you through each item and the expected benefit in a real life network. Hopefully that will be useful for your rollout. So very high level, what is connected mode DRX? It's a discontinuous reception while the UE is still in connected mode, meaning when there is no data for the UE, and after expiry of inactivity timer, the UE could go to sleep while still staying in connected mode. For how long? For a duration of long DRX to be configured by the network. And the benefit of that is that during that period, UE does not have to monitor PDCCH and burn battery. So this has been in existence since LT days and even before. And this is a very important tool to optimize device battery power on 5G NR as well. Now let us look at in the next slide how much is the benefit. So we have two sets of graph. Let's start with the one on the left. This is a scenario for VoNR traffic. And this is a scenario where a default CDRX, which is the baseline CDRX, is already configured in the network and it is up and running. And there is no BWP switching enabled. For a 100 megahertz TDD channel, the channel bandwidth is 100 megahertz and UE is monitoring PDCCH for the entire bandwidth. So what we are showing here is with a baseline CDRX configuration, what is the power consumption of a device running VoNR application, and if we could in the network configure a VoNR specific CDRX only for VoNR, we could save significant power of the device with respect to the baseline configuration. And if we switch gear to the right, it is similar set of studies with only difference is what if network already implemented DCI based BWP switching, do I still save power? And this graph is showing yes, we still save VoNR specific device battery power with an optimal CDRX configuration. So a very important takeaway of this slide is, does not matter whether your network has BWP or does not have BWP, with respect to what your default CDRX configuration is, we recommend that you also implement a VoNR specific CDRX in line with the scenario that we are capturing here. Your best effort CDRX still continues to be baseline, but with VoNR specific CDRX, you are able to save a lot of power. So CDRX continues to be a critical variable, and we recommend that you optimize that as much as possible. Now, switching the gear to bandwidth part, I understand bandwidth part is already implemented in many networks in China. So basically, idea is unlike LTE, the channel bandwidth could be as high as 100 megahertz, but depending on type of application, you may not always need to monitor 100 megahertz channel. So if there is a mechanism that can optimally switch you from small bandwidth part to large and large to small, there is an opportunity to save battery. So for example, where my mouse pointer is, here it is 100 megahertz channel, and we could switch to smaller bandwidth part. So we still monitor PDCCH, but we monitor PDCCH for smaller bandwidth and saving device battery consumption. How to switch, when to switch, these are configured in advance by the base station, and UE accordingly dances to that tune. Now let us look at the saving that we expect. So 3 sets of graphs representing 3 different application types. The first one is sync and idle. Your phone is mostly in idle mode, but there are some background activities that are going on, notification, etc. So that is represented by sync and idle, followed by a streaming type of application you are watching, followed by a WhatsApp or WeChat type of application that you are doing. And what these graphs are showing is, had the channel bandwidth been 100 megahertz and no BWP switching, the blue ones would have been our current consumption of the device. Now, if we implement BWP in the same 100 megahertz channel, since these traffics are not that significantly requiring 100 megahertz channel